Last on our list of Module 3 topics and operations on rational expressions, we've covered simplifying rational expressions. We've covered multiplying, dividing, adding, and subtracting rational expressions. That's pretty much it. Though there are cases where, and I'm thinking of calculus in particular here, where we do run across sometimes fractions within fractions. If you have a fraction within a fraction, we generally call those complex fractions, and these are complex rational expressions, and we do need to know how to simplify those as well. There are two main ways that are generally taught for simplifying complex fractions and complex rational expressions. Both involve finding an LCD because, as you can see in this example, we are adding fractions. So one way to work this problem is to go ahead and go according to order of operations, which is never a bad idea. And first add the two fractions in the numerator since those are grouped together. Then worry about dividing the results by b. And if you're interested in seeing that approach, I'd be more than happy to show you in one of the live sessions, or the tutors in the virtual tutoring lab can show you as well. I prefer a different approach, but both equally good approaches, but the one that I prefer involves something that we've talked about, something that we discussed in Module R this semester, which is clearing the fractions. So if we've got fractions within fractions, then we can actually clear at least one level of fractions, and in my mind, that's the simplest path to take and kind of gets us to our answer in a way that I can wrap my mind around. Here's the way that works. Look at all of the denominators in all of the smaller fractions, all the fractions that are within fractions. In this case, we've got a denominator of a and a denominator of b in our fractions within fractions here. That leads us to identifying an LCD of a times b. So our LCD is ab. And what we're going to do from there is multiply top and bottom by the whole LCD. This is what I mean. Multiply the entire numerator of the larger fraction by a times b, and multiply the denominator by a times b. I'm keeping things balanced because I'm doing the same thing to the top and the bottom. But the nice thing here is that when I multiply the top through by AB, I cancel the denominators and I clear the fractions. When I multiply here, 2 over A times AB, the A in the denominator cancels with the A that I'm multiplying by, no more fraction, and I'm just left with 2 times B. When I multiply 7 over B times AB, the b in the denominator cancels with the b that I'm multiplying by. No more denominator. 7 times a is all I'm left with there. Then in the denominator of the entire larger fraction, we've got b times ab, which is ab squared. B times b is b squared, so ab squared. And what that accomplishes by multiplying top and bottom of the larger fraction by the LCD is clearing the smaller fractions. Look, in one step, we've got no more fractions within fractions. In fact, we've just got one single fraction left, one rational expression here, and if I can't find a common factor, then I'm done. I can't simplify any further, and I can't find a common factor. Between 2b and 7a, there are no factoring, no common factors, no factoring work that I need to do there, or that I can do there. So this then is in simplified form. Let's see one more example of simplifying complex fractions in this way. Here we have another scenario where we've got fractions within fractions. We've got several, in fact, now. X over y minus y over x divided by x over y plus y over x. And if I look at each of the individual denominators of the smaller fractions, I see a factor of y, a factor of x, a factor of y, a factor of x. We don't have to repeat. We can just say I see factors of y and factors of x, so that my LCD will be x times y. And I'm going to multiply top and bottom by xy. Multiplying here cancels the y in the denominator and leaves me with x squared. Multiplying here cancels the x in the denominator and leaves me with y times y, y squared. Similarly, here we cancel the y and x times x is x squared. And finally here we cancel the x and y times y is y squared. So once again, in one step, identifying the LCD and then just multiplying everything top and bottom, keeping things balanced, multiplying everything by that LCD wipes out all of the smaller fractions within the larger fraction. Now we just have one larger fraction that we have to tackle, and if we can factor and cancel, great. And certainly we can factor x squared minus y squared. That's a difference of squares. That is x plus y times x minus y. But the denominator, x squared plus y squared, is a sum of two squares, and we cannot factor a sum of squares. So, knowing that we can't cancel factors, that is our simplest form answer.